Hello, welcome. This video is about the trig ratios, and I'm going to do a couple different levels here. I'm going to do approaching proficient and proficient here in this video. So in this first one, they asked us to identify the trig ratios of the right triangle, and we want to notice, excuse me, we want to notice that they are focused on A for each of these. And so angle A, I'm just going to mark it right here, but I'm also going to mark it with a little theta. This is the Greek letter theta. Theta. And it's we use it to that along with the alpha and beta to show like as variables to show angle measures. And so you'll see that this alpha then is I'm going to label this, the side opposite the right angle is always going to be the hypotenuse. The side opposite the angle that we're looking at, which in this case is A, would be the opposite leg. And then the one right next to it is called the adjacent leg. And all of this is in your notes. So if this is a little confusing, please look at your notes. The words are written out there, so you can take a look at those that way. If I switch, let's say I wasn't looking at the cosine of A or the sine of A and all of those, I would swap these. Those two would switch. The hypotenuse never switches. But if I were looking at, let's say, C in this case, then the side over here that it's pointing to would be the opposite, and this would be the adjacent. And so those switch depending on where you're looking. That's not what we have, so let's go back to the way we had it. This is opposite because we're looking at A. That's where our theta is. Theta. And this is the adjacent. And now that we have it labeled, we can use this, our mnemonic, so, ka, toa, to talk about those trig ratios. And the sine of A then is this one. It's the opposite. That's O over H. That's opposite over the hypotenuse. And so we would just put oops. Let's see. Back. Try that again. The opposite is 20 over the hypotenuse, which is 25. Now, if you put that in your calculator and you do the division, 20 divided by 25, and then you do the math, enter, then that will give you back 4/5. And so this is your answer as a simplified fraction. Notice here it says simplify all ratios, no decimals. So keep that in mind as you're working through the homework and on the test. Cosine, the cosine of A then is, let's go, let's say blue here. I've already used blue for the A. Let's cancel that out. That's the cosine of A is ga. You got to put the H on the end. Ga. And so that's the adjacent over the hypotenuse. And we cover that. The adjacent over the hypotenuse. And that would then give us the adjacent is 15. And the hypotenuse is 25. And that would simplify, both of those divide by 5. You can, again, do it on your calculator. You can do it in your head. Both those divide by 5, you get 3/5. And so that would be the simplified ratio in this case. Now the tangent of A, toa, is O, the opposite, over the adjacent. And so we've got 20 over 15. And both of those, again, divisible by 5. And so that would be 4/3. And that would be the simplified ratio. Now, the reason that we have labeled these out here, the cosecant and the sine, The S here in sine, I got to think, goes with the C, and the C in cosine goes with the S in secant. They're reciprocals. And so the cosecant, from this, it's not that hard. You can kind of jump that the cosecant then is 5 over 4. The sine is 4 over 5, so the cosecant is just that swapped on again, like I said, the reciprocal. So the secant of A, since the cosine is 3/5, the secant of A is 5/3. And the cotangent of A, again, the reciprocal of tangent, since the tangent is 4/3, the cotangent would be, you guessed it, 3/4. And that's how you would do this first one. So on the proficient, we have to figure out what this x is first. And so we're going to use the Pythagorean theorem. I'm going to say x squared plus x squared plus 7 squared equals 8 squared. And that's x squared plus 49 equals 64. Then I'm going to subtract 49 from both sides. And that cancels. X squared then is equal to 64 minus 49. I don't usually, 64 minus 49, my brain's a little tired, so I'm going to put this in my calculator, is 15. So this is 15, and that means that x then, take the square root of both sides, x is equal to the square root of 15. And we would just leave our answer like that. So x is equal to the square root of 15. And then we can put these ratios together. Again, sine, we've got sol, that's O over H, but we need to look at where theta is at. So theta, we need to label this. This is the opposite leg, opposite the right angle. That's the hypotenuse. I'm just going to put H there for hypotenuse. And then right next to the angle theta is the adjacent leg. And so now I can put sol is O over H, that's 7 over 8. The tangent is O over A, toa, so ka toa, toa, that's 7 over root 15. 7 over the square root of 15. So again, that's O over A. And we've got those numbers, 7 over root 15. The secant that they've asked us for, remember that the cosine of theta is equal to 1 over the secant, and vice versa. The secant of theta is equal to 1 over the cosine. They are reciprocals of each other. And so if I know that the cosine is, that's ka, so ka. The cosine is A over H, since the cosine of theta is square root of 15 over the H, over the hypotenuse 8. That means that the secant is swapped. So it's 8 over root, sorry, that's messy, 8 over root 15. And that's how you do it. Let's see. En español, I'm just going to make note here. We're going to look at 8:55. En español, dice que hay que identificar las razones trigonométricas de este triángulo rectángulo abajo. Y nos han dado que este es 15, este es 20, este es 25, pero todos están en A. Esas 6 razones trigonométricas tienen el ángulo A. Entonces vamos aquí a A y ahí he puesto θ para identificar, y opuesto de θ es el lado opuesto. A su costado es adyacente, adjacent, y siempre opuesto del ángulo recto es la hipotenusa, o en inglés hypotenuse. Entonces eso nos ayuda a usar so, ka, toa, que es la mnemonic, que nos ayuda a recordar cómo ponemos las razones trigonométricas. Este sine es hypotenuse. Entonces el sin tan amarillo, so es O sobre H. Entonces ponemos 20 sobre 25, así. Y cuando lo simplificamos, se simplifica a 4/5. El cosine K es A sobre H. Eso es adyacente sobre la hipotenusa, hypotenuse. Entonces ponemos 15 sobre 25, se simplifica a 3/5. Y luego, la TOA, tangent, es O sobre A. Eso es 20 sobre 15, así como hemos mostrado ahí. Y se simplifica a 4/3. El cosecant, el secant y el cotangent simplemente se cambian de lugar en cada uno de los casos estos. ¿Ok? Así es como se hace. El cotangent es el recíproco del tangent. El secant es el recíproco del cosine. Y el cosecant es el recíproco de sine. Entonces, así es. Ahora, en el segundo, perdón, que voy un poco rapidito. Primero tenemos que encontrar este lado faltante, x. Entonces, si pongo x cuadrado más z cuadrado es igual a 8 cuadrado, x cuadrado es igual a más 49 es igual a 64, se resta 49 de ambos lados. Eso lo elimino a la mano izquierda, pero dejando x cuadrado solo, igual, y 64 menos 49 es 15. Si x cuadrado es 15, la raíz cuadrada es x, entonces igual a la raíz cuadrada de 15. Entonces lo mostramos que x es igual a raíz cuadrada de 15. Lo ponemos las etiquetas. Θ está aquí, entonces ponemos que el SO es el opuesto, 7, sobre la hipotenusa, 8. 7 octavos. Ese es el sin de este ángulo en particular. Y el tangent es TOA es O sobre A o 7 sobre raíz cuadrada de 15. 7 sobre raíz cuadrada de 15. Y luego el secant, vamos a poner azul, el secant, hay que recordar que secant, 1 sobre el secant es igual que cosine y el secant es igual que 1 sobre el cosine. Entonces se cambia. Y si el cosine, que es K, A sobre H, a ver, A sobre H, eso es radical 15 sobre 8. Entonces para el secant simplemente se cambia de lugar. En vez de radical 15 sobre 8, es 8 sobre radical 15. Y así se hace. Sigue trabajando duro, si se puede. Sí se puede, sí se puede. Ahora, chao chicos, hasta luego.